Bonjour, merci de participer à cette session de DataXDays. Le prochain talk sera en anglais, so I'm switching to English right now. Our last speaker of the day is a test automation lead at Siemens. He is going to talk about machine learning assistance for software testing. Let's welcome Mesut Durukal. Mesut, thank you for speaking at DataXDays, and the public is yours.
The nice words. So thanks for the audience as well for joining my session today. In the session, I will going to talk about some practical machine learning applications in software testing area. It will be a quick session, so I will be going a little fast. But please do not hesitate to reach out to me for any questions or recommendations for any of the applications. So in the slide, you can see some communication channels and for contact information for me. And as you already know, my name is Mesut, and I'm working as a QA engineer at Siemens Istanbul office. And as I told, even after the session or afterwards, please feel free to ask any questions or any recommendation for the further work. So in the session, we will discuss some machine learning practices in software testing area in different stages. As you know, software testing lifecycle starts with the analysis of the requirements, and it continues with the progress with the implementation of test cases, if you are dealing with the automation of test cases. And finally, we perform some maintenance issues and some maintenance tasks and jobs. And we will discuss what we can do with the assistance of machine learning in all these stages. And finally, I will share a real-life scenario and real-life application that we tried with my team. It is about the classification of the bugs, the Jira issues, and we tried to classify them into severity levels to different 6 classes. And we will discuss the first outputs and the performance of the classifiers. So firstly, I want to start with an introductory session in which I will discuss the necessity of the machine learning assistance, because normally we know that some data scientists and some machine learning experts are closely involved in the research for artificial intelligence and machine learning. But as software testers, should we really involved in the issue closely, or why should we bother ourselves to search some implications or search some integrations of machine learning into software testing effort? Actually, we can have some benefits from these adaptations and integrations because we have some challenges. For example, in the modern software testing world, we have a great rivalry in the software market, and everyone is trying to be the first in the market. We are all in rush, and we have a limited time to verify and validate our scope. And we have a complicated scope to verify, to test. And as I told, we have a very limited time to test them because sometimes for the deployment time, we have 1 hour or maybe 30 minutes for the testing window just before the shipment to the production environment. So we can say that it is really a limited time, and we have a very large and complicated scope to verify. Maybe we are dealing with hundreds of test cases to be executed. So this is a real important challenge, and we are living in an agile environment, and we face and we encounter too frequent changes and updates. So these are all efforts requiring some manual effort. So we are searching for help to reduce this manual effort from the automation or from the automated tasks which can be performed with the help of machines or with the help of automated environment. So they can really help or not? Can we get some benefits from the machines? Actually, yeah, we know that machines are programmed by the human beings already. So they have some limitations and they have some limited capacity. But on the other hand, we know that they have some advantages as well. For example, machines do not get tired, right? For example, as we human beings get tired. For example, at the end of a long working day, it is very likely to overlook some weaknesses of the product. At the end of the day, we can miss some bugs because we get tired and our brains are performing not well at the end of the day. But for machines, it is not the same situation. They perform almost same at the, every moment of the working cycle. So it can be regarded as an advantage for the machines. And additionally, we can create simply additional resources. For example, for the limited stress time, it is not easy to create additional human resources. For example, when we have lots of test cases to be implemented or to be executed, we can ask our managers or request our managers to add some additional resources. But it is not easy to adapt immediately some additional teammates to the work. It is not easy, it takes some time. But for machines, you can immediately create another virtual machine, right? It is very quick and it can be very quickly adapted into the resource pool. So it can be regarded, again, as another advantage for the machines. And we know that they don't have emotions. So we can discuss about it if it is an advantage or a disadvantage, because sometimes we as human beings reflect the emotions or the situations of our end customers. So, and we need to have some soft skills as software testers. So machines do not have emotions. But on the other hand, they have some advantages as well. And we already start to see that they started to overperform some human beings. For example, we know that on some games, for example, Go or some other complicated games, machines or robots already started to beat human beings. And they started to beat the champions of the games. So if they are correctly utilized, we can imagine that machines can be integrated into the work properly. And actually, we already started to see them in different applications in our daily life. For example, this table depicts just a sample set of different applications or platforms which utilize machine learning. But these are just the ones concentrated on the software testing area. But for our daily life, we already know that when you are surfing on the net, you are recommended with some further pages, the relevant pages. For example, the machines already understand which topic you are searching for, and they are recommending some additional related stuff to you. They observe your movements, they observe your patterns, and they understand what you are trying to do. So we know that they are adapted into too many platforms. For example, when I'm writing over my email account, I noticed that when I started to my sentence, it is automatically completed. It is automatically finished by the machines. And most of the time, I see that it is really the rest of the sentence that I want to write. So it eases my tasks and it eases my effort. So I'm happy when the sentence is completed, because in this way I get rid of the rest of the manual effort. So they can really make life easier for us. As I told in the beginning, just the only thing that we should do is to properly integrate or to properly adapt them into our lives. So we are talking about the learning. So in this point, we should discuss about the meaning of learning. So what does a learning mean? Actually, in this point, learning is something different than memorizing something, or learning is something different than explicitly being programmed or implicitly being programmed. For example, let's imagine this with a real life scenario. For example, when a baby touches to a hot object, at the first, he doesn't know that he shouldn't touch to the object, right? Because he feels a pain in his finger or in his hand. So, but at first, since he does not know it yet, he touches to an hot object, and afterwards he cries, and he knows that he should not touch to the hot object in the next time. So after he sees a cup of tea, in the next time, if he sees a cup of coffee instead of a tea, He does not touch again, right? Because he already understood how the system works. He already understood the model and underlying principles there. Tea or coffee is not same as tea, but again, it is similarly working. So he did not memorize. He did not memorize. He should not touch only to the coffee, but he understood and he learned that he should not touch to any hot object. So just to get rid of the pain. And when you see the image on the slide in the middle, you can imagine that it is a chair, right? But because how do we know that? Because we already know that from our lives, a chair is an object on which we can sit. It is not a classical chair. It does not have four legs, but we understood the working principles of the system. So we can imagine that it is a real chair. So we learned the system, and the one who firstly asked this question bravely on his time was Alan Turing, and in 1950s he had an article about whether the machines can think or not. And on that time, it was real a bravery to ask these kind of questions if machines can think. So he proceeded on his work, and we can say that nowadays it is a major study about machine learning, and nowadays lots of researchers are concentrated on the further progress of the issue and the further implementation, such as deep learning or similar stuff. And we can say that it's really the learning algorithm really works very similar to our biological working principles. For example, when we see a cat, we understand in our brains gradually. For example, first we see the cat, we understand that it cannot be a lion because it is not that big. So we eliminate the classes. We want to classify the object. Okay, can it be a lion? No, it is not that big. So we eliminate that class. And the rest, if it is a dog, if it is a cat, so we go one by one. We go gradually. So it really looks like a hidden patterns and hidden layers of the mechanism. So the deep learning is really looks like or works similar to our biological learning principles, and the perceptrons are very similar to nerves in our body. So we can say that they are inspired from the working principles of living organisms. So I assume that everyone who joined this talk is more or less aware of the issue, the background principles of machine learning working models. So I will skip this part quickly. And we can say that we can apply different algorithms according to our problem. Our problem can be a supervised learning problem or an unsupervised learning problem. For example, in our case that I will share at the end of the slide, the issues are labeled. For example, I create some issues on Jira and I set their severity classes. For example, when I create an issue, I label it with a high severity to the developers, or I set it with low severity label. So in my case, it is a supervised learning, but we can be dealing with some unsupervised learning, for example, clustering issues or some other issues. So we can apply different related models or classifiers. So we can pick the correct model accordingly. So I will quickly investigate the applications that we can integrate into our stages, software testing stages. And in a classical software testing lifecycle, we start with the analysis of requirements, and we design our test cases, and we implement the test code, and finally we execute the implemented test code, and we maintain them. And if we have some we find some vulnerabilities or weaknesses in the product, then we raise some issues in our track or management platforms, and we continue with the maintenance stuff. And in all stages, we observe an input and output relationship. For example, according to the requirements, we design some test cases, and there is a traceability between them. So we can construct a model between those inputs and outputs. And in all stages, we can integrate some applications. And let's go one by one, which or what we can do in all stages. For example, for the test case definition, first of all, we have to understand how the system works. For example, as a software tester, when someone comes to me to test something, the first thing I will ask is, okay, I can test your product, but first of all, teach me. First of all, let me learn how your product works. I send some requests, I observe my inputs, and I observe the according outputs. So I want to construct a model according to those input-output relationships. So it works similarly. And for the API side, the model or the machine can observe the request and the upcoming responses relevantly, and it can understand that, for example, in this example, it can really understand that when we have an endpoint related to books entity, it can observe that there are some book entities inside, and there are some ISBN information inside, which is represented by a string value. So it can construct itself automatically by injecting some string values inside, or it can construct some negative values. For example, it already learned that ISBN number is represented with a string, so it can inject some integer numbers inside to construct a negative request. So in this way, it can construct a test case, and it expects the negative response at the end of execution of this case. So for the UI side, it works similarly. And when we go to an online shopping site, for example, for the first time when we go, and if we see a shopping cart on the page, we understand that if we find some items, those items are added into basket, right? How do we know that? Because we navigated to some other systems before in advance, and we already know that a shopping cart represents the items that we bought, right? So it's we already learned how it works, and we can construct some test cases accordingly. When we see a shopping cart on the page, we can construct we can create some test cases which consist adding some items to the basket and with the further steps. And after the implementation of or design of the test cases, we can construct the test code as well. For example, on this example, which we can see on the screen, according to the input-output relationships, it can understand the relationship between the input and output. For example, for this pair, for human beings, it is not very easy to understand the relationship between input and output pair. But for a machine, it is very straightforward to come up with the relationship between them. For example, every value in the input set is multiplied with 4 to reach to the output on the screen. So the relationship is solved by the machine, and accordingly the algorithm is applied. So the code is automatically generated in this way. So all these applications help us to reduce the manual effort, because all those tasks are performed automatically in this way. And for the UI case, for example, it is very cumbersome for software testers to maintain the front-end automation side, because sometimes the code is broken after the code is changed on the front-end code. So instead of performing traditional UI code, we can go with visual automation of the objects on the page, and in this way, the test is barely broken, and the maintenance effort is really reduced in this way. And for the execution side, the executions can be performed automatically, and in this way we can collect some data. For example, in each iteration we can collect the execution durations, and we can perform some pattern recognition cycles. For example, if execution is out of the bounds or out of the limits that we expect, because it already learned that an execution should be completed in a certain range of time. And in the next iteration, if it is out of that limit or out of that range, so it can be understood that there is something wrong. And similarly, we can maintain some issues to refactor our code. So I'm about to go out of time, so I will go quickly in this part. But as I told, we can apply some tasks to refactor our code as well, and self-healing code as well. And lastly, for the prioritization part, it is important to make some prioritization because infinite testing is not possible. So we should be selective enough to go with a selected set of test cases to be implemented or executed. So for the prioritization, we can apply some models which estimates which test cases are the most prior. In this case, or in this way, we can select the most prior test cases with the help of machines, and we can make some classifications or clusterings on the bugs. And I will illustrate one sample scenario for this. For example, in this study, we tried with my teammates a classification in which the bugs are labeled with 6 different severity levels. And after the extracted features, we tried to classify them. And we see that for this example, it was not very successful and it was not performing very well because we see that there is a tendency to classify all the items as the severity 2 because the data is biased enough for such a misleading. And in the next cycle, which we did is to separate the data as severity 2 data and the data which is not severity 2. And in this way, the data was more balanced, and we reached to 82% success for the classification of these issues. And we can say that finally, maybe, okay, some predictions or some estimated items are classified as wrong estimations because we saw that the machine estimated them as, for example, severity 3, but the creator had labeled them with severity 2. So we say that this is a wrong estimation. But normally, maybe the machines are covering all the previous data more than you. What I mean is when you are creating a bug, you are not checking all the previous items to check how the other guys in the team are creating, right? So just to maintain the stability or maintain the standard. But maybe the machine is saying the correct prediction. Maybe we can discuss about it. And there are still some further progress to improve our algorithm. And finally, this was the summary for my session. There are plenty of alternatives for us to apply some machine learning adaptations on different stages of software testing study, starting from the requirement of analysis and generating test cases, till the maintenance of the issues, for example, bug classifications or bug clustering issues. So thanks for listening to me, and this was a really quick session. And if you are really interested in the implementation or the details of the implementation, please feel free to contact me. And thanks again for listening to me, and stay safe. Bye. Thank you.